let people in. Okay, good afternoon, everybody. Welcome to the next session in EAMS 2020. We've got a couple of demos of new software for you today. I will just show the program. First of all, we have Matti Harjula from Aalto University in Finland talking about a new question type based on Stack called Stateful, and then David Lipman is going to demo MyOpenMath, which is built on his iMath AS system. Okay, so I think we'll get straight into it. I need to unmute Matti, and there you go.
Okay, so sharing my desktop would be the first thing, and then the slide. So I'm Matti Harjula. I have been a developer of Stack since Stack 1, so over 10 years, and I have supported the use of Stack in Finland and especially in Aalto University for most of my professional career. And during that support, I have helped our question authors express themselves and created various types of extensions to Stack so that they can do whatever they want to do. But there were some issues that could not be solved. And in this talk, I will be representing a new question type that has been built on Stack and showing how it can be used to solve certain issues that Stack and most other systems tend to have. At the end of the demonstration, I will be showing how to author actual questions or how to deal with the complexity of authoring this type of question. So first onto the history of Stateful. So things started to become difficult when using Stack in 2012 and trying to do questions for industrial management types of teachers. They wanted to create simulations, the questions where you first ask something and then based on the answer ask something else, and based on that maybe generate some random event and check how the student reacts. Obviously, doing that kind of a thing in Stack or any other stateless system is difficult as you can't change the question on the fly. But one of our best question authors managed to still do it by making a Stack question where there were multiple inputs, and when they gave an answer to the first input, the feedback to that input would then give you the next question. And then you gave an answer to the next input and so on. Obviously, dealing with all that was slightly difficult. So after that, we started to trial with JavaScript and building some kind of a dynamic behavior on the browser side. But it was difficult also, as acting with JavaScript isn't exactly something that belongs to the basic skills of your question authors. And browsers are a moving target, and these materials tended to break down. There were also some security issues related to that, but maybe we'll ignore those. So in around 2015, I managed to come up with an idea of how to extend Stack so that we could do stuff. And as the idea seemed to work, we demonstrated it at EAMS 2016, and everyone was happy, but not me though, because authoring questions with that new concept didn't really work. It became very difficult to author large questions, long questions, as you had branching in the questions, and testing that branching was practically impossible. So we refined that idea further and started to search for funding to implement it. And in 2018, 2 years ago, funding materialized. So if you tag your dream project into a massive collection of projects, someone might actually fund it without noticing that they were funding it. and the Finnish Ministry of Education managed to give me some money to code. And unfortunately, that happened just at the time of EAMS 2018, so I had nothing to show and was heavily coding. But in EAMS 2018, there was a specific keynote by Mohammed Yabara that gave us the terminology to use when talking about stateful. So stateful is all about inner loop adaptation. Adaptation based on the current activity of the student in this question. And if you haven't seen that keynote, I highly recommend watching it. It will teach you much about adaptation in educational materials in all scales. Okay, so last summer we got the prototype done, or the new version, and initial testing began with various types of authors, mainly physics teachers, and they came up with very interesting new use patterns. And then we did more development. And now we are finally at the point where we are exposing students to stateful or stateful to students this fall. And after that, we will see if it actually works. So the main point to remember here is that stack and stateful are very tightly coupled. So stateful is basically just stack with state, like it was all originally advertised. So it uses all the stack features that we love so much. And as it shares all the internal parts of stack, we can benefit from the developments of stack, and stack can benefit from the developments of stateful. And this is basically where they overlap. So the key concept in stack is these potential response trees, and stateful very much uses that. We also use all the stack maxima libraries and all this evaluation and security features related to that. But stateful will never be able to do deferred feedback, as that kind of a behavior won't work in a question that relies on interactivity. And stateful will probably be a bit slow in gaining all the newest ideas from Chris, and maybe stack won't get my newest ideas either. But stateful will soon bring new performance improvements to stack. And stateful will probably get the rest of stack's inputs soon also. So basic terminology related to stateful. So stateful questions are basically just a collection of stack questions, just parametric questions, like if you were to use computer adaptive testing or similar constructs. But the idea here is that when your question classifies the student's input, it can decide that now we are going to give change to the other question in this collection of parametric questions and set the parameters accordingly. It can also store some details into memory and use that to adapt the next time it has to make some kind of a choice. In stateful, the term for one of those questions is a scene, and the obvious term for analyzing student activity is a path. So which scenes did the student visit and through which transitions they went through the graph of scenes. Here's a graphical representation or style for representing questions, showing two basic patterns for stateful questions. So the most common pattern we have seen in materials authors thus far is the so-called penalty lap. So you have a question here, and depending on how the student answers, if they answer correctly, they go to the next scene, skipping this loop. But if they were to answer incorrectly, we might have a counter that counts how many times they have given this particular incorrect answer or any incorrect answer. If the counter isn't too high, they might just get to try again. But if it's too high, then they will be sent to a penalty lab where they go through lessons and answer questions related to those, and until they have passed through all those lessons and get back to the question, which they then attempt again. And the state will remember that they have gone through this loop and there's no need to go there anymore. This can also be used as a way of doing intermediate steps. So the logic could be that first you ask the end result, and after that you ask the intermediate steps, so that you don't show the steps or scaffold the answer by showing the slots where the answers to those intermediate steps would need to be placed. Or you could use those intermediate step questions as a part of this penalty lab to help the student to understand what steps they should take. Okay, then there's this horrible graph where we have the option of student choosing from multiple potential solution paths. For example, we might have a physics exercise where they could use energy principles to calculate some kind of a solution, or they might go through kinematics or dynamics or something like that. But if we give the student the choice of selecting the method, then we need to also give them the choice of changing their mind, which causes complications and all these transitions backwards. And if we have such transitions, then the student's grading needs to take into account the fact that they might have started some process, done it halfway through, and then gone back and done a separate process on the side. So these are rare, but we have already seen those in exercises. Also, it might be that the student doesn't make the choice. We might analyze the answer, the shape of the answer, how much it has been evaluated, how much it has been simplified, and do the choice for them ourselves. And finally, it doesn't require, these questions do not require that there's a just single end scene. So a path through the question might lead to two different end results, depending on the structure of the question. Okay, then some future plans related to stateful. So for now, stateful only has local state. So the question updates its own state. But obviously, interesting development place would be to connect stateful to learning analytics. So that if we already know that a student knows how to differentiate something, we might skip the steps in a question where you do differentiation and instead add some steps that do something more interesting for that particular student. But handling such state is kind of difficult and we are not there yet. Also, analyzing massive amounts of students is a difficult task, and for that we need to be able to visualize how these groups of students divide up into various paths, and current aim is to build Sankey diagrams. Sankey diagrams were originally built to track the energy flows in a steam engine, and as we are now doing physics exercises with physics teachers that are trying to do thermodynamics papers, so we feel that it's natural to use the same terminology for them. Okay, now on to this year's sample question. I'll simply show the state graph here before we go to the demo. So in 2016, we had this integration by parts question where you could integrate to the wrong direction infinitely. And the question gave increasingly snarky feedback about going to the wrong direction until the student guessed that they have to change their strategy and go to the correct direction. Now the question doesn't have a loop. It has two penalty labs related to possible types of errors. And in this type of a question, you need to be very careful reading it. So we are asking the areas shaded and not the actual definite integral of that polynomial. So you have to integrate the absolute value. If they miss that little detail, you will get very specific feedback about it. On the other hand, if they give something completely different, they will be taught to integrate a polynomial, or they will be asked to integrate a polynomial. And this is the whole question in terms of stateful concepts. So we have a scene where we start and a scene where we end. We have a scene where we check that you can integrate the polynomial, and a scene where we check that they know where the signs change. Then we have state variables that keep track of the types of transitions they have made or types of errors they have made. For example, if they did make this error, we specifically remember that. And then we have transitions that have specific rules. So if they give the correct answer, then we give them some points, depending on how many errors they made. And if they make a particular type of error, we will go to the penalty lab if they haven't been there already. Okay, so now to the demo. You all have the permission to go to the demo site, and you all have editing rights there. So if you want to try making this yourself or breaking these questions, feel free. They should remain active for you for a couple of months, maybe not to the end of the year like some other services, but still it's pretty much the only place where you can test this. Okay, and then to the actual question. Oh, those probably are. So yes, the question that probably someone has tried. So this is a JSF graph for those that didn't already see the demonstration. And if I give it something stupid, it should validate it, and I should end up in a scene where I have to integrate that. But why would I test it by typing in these details? That's kind of difficult to do if you have a long question that happens to branch a lot. For that reason, Stateful provides specific tools for defining what to fill into these fields. So in basic Moodle questions, you have this fill in correct responses, which is a nice way of testing your material. But if you have a question that has multiple possible sensible inputs or multiple inputs that cause specific feedback or errors, testing them is slow. Therefore, Stateful provides a list of certain test inputs and checks if they actually do what they should do, and if they can do anything in this specific state. And you can simply fill in that input and check what happens. After that, it will then shift to that scene and give you the new set of inputs that are possible. In this case, they ask me, or the question asks for the points where the sign changes. There are plenty of hints. The question is obviously difficult, not pedagogically sensible, but technically interesting. And to give 3 routes, we would probably need 3 spots. And as I don't want to calculate them myself, I just click that and get them. Now we would then return back to the start scene, where we see that, yes, let's try it again. And these are the details that we already figured. Now calculate the correct one. And filling in the answer is relatively easy, and then you are through the question. Fine. But what's the interesting bit when doing these kind of questions is the complexity of the authoring process. So if we were to change that question in such a way that in some particular state it gives some kind of a feedback, how would we quickly test that that feedback gets outputted in those scenes that we care about? So we have a stateful editor, and obviously no one writes that code. So we are using a specific editor from somewhere else where that is built for stateful. In it, we can access the logical questions or the stack questions that make up this question, where we have basic rules for generating that polynomial, and at some point some graphing rules, and at the end these state variables that have been initialized as false. And then it has a scene, this question, that has a specific conditional rendering that says that if you have been in any of these error states, let's put this, now let's try it again, comment there. And if you have been in particular scenes, then we draw these. You have already found out these kind of things, details. But what I want to do is I want to put into the end scene a comment about the engineer's method of solving this kind of a problem. And I already made the text, and let's see if we can get it working. So I'm guessing that most people would use this method. Just pick large enough b. You don't have to do absolute values. Now let's save it and see what happens in the preview. We go with the correct answer. We don't see anything. Okay. Now the option would be to simply try all the possible combinations and see what happens. No one has the time for that. Therefore, we have tools that can simulate all the possible input actions and sequences up to specific depth for multiple variants and so on. So we are interested in the end scene, and in particular, the cases where we have the sign error. So does that have the comment? Yes, it has. And that shouldn't have the comment. Yeah, good. So making the system automate all these testing steps is important for those that want to answer these questions in any larger scale. So if you are a super coder, you can probably just simulate all of these things in your head, but it is not realistic to expect that from any real question authors. And that was the reason why stack with state died and stateful was created. It has more sensible question structure, question model that can actually do these kinds of things. And you can use this tool to check what it would look, or what the plot would look in various different variants. Okay, but I'm guessing that's about it for that part of the demo. And thank you for your time. And if you want to know about stateful, please contact me. If that editor looked nice to you, please contact my commercial alter ego that builds editors for stack and stateful and so on. And now I hope that Christian will handle the questions.
Yes, I will. Thank you, Matthew, for that talk. That was really interesting. Since your talk in 2016, I've implemented a similar feature in numbers, so I'll get a copy off you again. We have a couple of questions on the Moodle site. First of all, Ingo Dan says, is there a documented interface between stateful and stack that would allow for using stateful with another test system? So I guess, could you just clarify what the relationship is between stateful and stack?
So stateful is a complete new question type that just requires stack. So it's a Moodle question type like stack. So if you have a Moodle, you can just use stateful, but they don't really connect directly, or stack or stateful don't really connect directly to each other. And as you see in the EAMS site, you can just use LTI to push your stateful questions to any system you want.
Yeah, so Moodle can expose courses through an LTI connection, and that's how you would use it with any other virtual learning environment.
Yeah, at this point, but obviously it has been built in such a way that it could be ported into some other platform. And there are APIs actually in the stateful so that it could be used in a server mode somewhere.
Actually, now thinking this is probably a question about can you use this with Ilias? Is that right?
Well, not yet. I guess that Ilias could do it, but I don't know that much about Ilias at some point.
Okay, we have one more question from Martin Kraska, who says, is the dynamic matrix input available in Stack? I think you showed a matrix that you could change the size of.
Unfortunately, not yet. So stateful is a proving ground for many new features for Stack, and that input type is in the new input 2 system that is not going to be in Stack very soon. It will probably take a year or two to get it into Stack. But there are actual dynamic matrix fields in Stack or coming very soon from other people.
Yeah. Okay. Right, thank you. I don't think we have any more questions now, unless anybody wants to peep up now. No? Okay, well, so thank you again, Matti. And we will move on to our next speaker, who is David Lipman, who's going to talk about MyOpenMath.
Okay. Well, good morning for me. Afternoon for most of you. So I am David Lipman. I have been teaching for 20 years at Pierce College, which is a 2-year college in Lakewood, Washington, in the United States. And I started iMathAS about 15 years ago now. It was one of those things where I was frustrated with the cost and inflexibility of the publisher systems. Teaching at a 2-year college, we don't have very extensive IT departments, nor much flexibility to do things on our own. And so most of the existing systems out there were too complex for our IT folks to handle. And so I created iMathAS with the idea that it could be run on a commodity LAMP server with no additional software. So very simple installation. As it turns out, even that was too complex for most of the IT folks. And so with some state support, we ended up creating a hosted instance for everyone in our state to use. And then eventually that evolved into MyOpenMath, which is now a hosted installation of the iMathAS software for anyone who wants to use it. But the software is available and can be installed locally. We do have a number of school-specific installations out there, so that is possible if you want to do that. The big focus of MyOpenMath has been around supporting the use of open textbooks. So we are textbooks. The nice thing about having a hosted platform is that with everyone on the same system, when people create questions, they're instantly available for everyone else on the system to use. Likewise, the user community has created a lot of sort of starter courses aligned with open textbooks, so it makes for a very easy start. Again, our main audience has been 2-year college faculty, which is like freshman and sophomore level students, as well as secondary schools, high schools. So the content has mostly focused on sort of the arithmetic through calculus levels, and there's been a real focus on making it really as friendly as possible for the students to use. The system is set up with enough LMS features that it can be used standalone, but it also can integrate with an LMS using LTI if you prefer to do such things. So that's the basic gist of it. Let me hop into actually showing you a little bit what it's about. So I have 2 links in the Moodle course. One is sort of your typical LTI integration where you integrate a single assessment and then you can get the grade return back into the LMS. And then the second link launches to a full course giving you sort of the experience of using MyOpenMath standalone. So I'll just hop in and let's take a look. So I just sort of threw together a demo that would go through a variety of question types. And just to give you some sort of idea how it works. So this is sort of a boring question, just a standard numeric question, but shows sort of the dynamic graphing capabilities. It is set up with all your standard features. Okay, so it's got your algorithmically generated questions, your auto grading of numeric, graphical, and algebraic answers, and dynamically generated graphs and things. So like in a typical homework, if a student misses a problem, you give them a couple tries, show them the answer, and then if they want to try a new version of the problem, they can generate a new version of the problem for additional practice. Anyway, so basic numeric question, like an answer that would have sort of a fractional answer. So we do have sort of your MathQuill, nice friendly equation editor entry here to help the students put in their answers. A lot of the community created content has linked in things like videos in with the questions so that students have access to, I don't know if that came up in the screen share, but have access to video resources as well if they need help. So here you got your standard algebraic answer entry questions. So students are putting in any algebraic answer that would be reasonable. Let me see if I can actually get one right. I'm not very good at getting things right while doing demos, but we'll see. And it gives them some warnings if they do silly things. Yeah, I got one right. System of equations question, complex numbers, matrix answers, either interval notation, inequality type questions, or actual inequality notation, inequality questions, as well as things like, graphing on a number line. So you can graph, solution intervals, multiple choice questions, including things like and 3D graphing, basic 3D graphing capabilities. One of the things I'm most happy about is we do have some sort of graphing entry questions. So it is possible for to ask students to like graph an equation. And for basic equation types, you're not seeing all of them here. This is extendable. You can also do, cubics and basic cubics and sine and cosine and exponentials and logs and things like that. So for basic equation types, you have this sort of 2-point entry type where you just plot 2 points on the graph and it draws the curve. So they can easily enter a graphical answer, which is kind of nice. Of course, things like multiple answer questions. There's also some, in the question writing language, we have a lot of sort of functions, macros for doing things that come up in math. So we have a lot of statistical functions. And because we teach this sort of math for liberal arts majors class that includes some graph theory, we even have some graph theory macros. So this is a dynamically generated graph. There's just a function that generated it. And of course, like multi-part questions where you answer a bunch of steps in a question. In this case, a sort of hypothesis test question from statistics. This one is we have sort of your standard questions have like one answer, right? And you score that answer. And in order to make it as easy as possible for question writers, usually you just say, here's the answer, and that makes your life easy. This question is one where it's sort of has a custom evaluator where it's determining, it's having to actually look at the student's answer and compare it to some parameters to decide if it meets the conditions, right? So like any graph that has a positive slope and a negative y-intercept. So this one, we don't have what Maddie was just talking about with the actual branching, but we do have sort of the step-by-step questions, right? So where you can see it's broken down into 3 parts here. So the idea is that, sometimes you don't want students to see the answer to see the second part until the first part's answered. So they have to answer the first part correctly before the next part shows, and then they can walk through the the parts or steps of the question. And there's also capability for things like essay answers and file upload questions. So if you want to actually collect students like written work on things, you can do that. There's even capability to just add a attach work button to the questions where students can, you know, answer the question using the auto graders, but also attach work to the question so that you can manually grade it. That's come in very handy in the last couple months as we've been stuck at home, being able to grade students' work on exams. And then these last two examples are just some integration style examples. This one is a GeoGebra applet that is integrated into the question, and we get the results back, or the interactions back, and we can actually score them in the question. And then this last one is a little JSX graph widget that, again, we are reading back the results on so that we can score it. Yeah, and so that's kind of the question types and sort of general interface of the system. That's what it looks like. To hop in, let me hop into the other one. So if you hop into the other one, again, you'll see sort of the standalone interface. When you look at it, you're going to see it sort of from the student view. So you'll see that we have content items, text items, folders, links, web links out to content. So we can use, like I use this standalone in my online classes to deliver my entire class. So I have my links to the textbook material, I've got video lessons for the students to do, and then I've got the homework assignments for them to work on. I've got quizzes and things like that as well. Yeah, that's a general gist of the system. There are a few other features I'll mention. First is, the example I showed earlier was sort of what we call a homework style assessment, where if a student misses a question, they can ask for a new version on a per question basis. We also have a quiz style assessment where the student works through the quiz, and then you know, when they're done with the whole thing, they'll hit submit. And then if they're not happy with their score, they can if you give them the option to, they can retake the whole quiz, and then you can, you know, keep the best score on all the retakes, things like that. And there are some other weird ones like what we call video cued assessments. And so this is where you have taken a video, sort of a longer video, and I think it's playing, yeah, sorry, just no movement yet. And then at certain points inside the video, you set up triggers where it will stop the video, and it pops up a question. And then the student can answer the question, and then depending upon whether they're right or wrong, they can, you know, continue in the video. It's kind of like those Edpuzzle style websites where you can integrate questions in with the video. It just gives you the ability to use any MyOpenMath question in with your video. So I can intersperse multiple videos. This is kind of nice for, I found this particularly nice for doing like interactive lecture sort of stuff, where like if you were in class, you would pause and say, hey, what do you think about, or give this question a try. So I can basically ask that in my video and then actually pop up the question for them to try, and then follow it up with the answer, and it encourages a little bit of interaction with the video lecture. The system also has what we call a live poll system, which is kind of like a Kahoots or Socrative. So it's a WebSocket-based system where the students are on their phones or on their laptops, and when I open a question, it pops up on their system, they answer the questions, and the results tally on my system live, and so that we can talk about it in class. That one's not easy to demo, so I'm not going to show you that. Yeah, that's about it. And again, on the instructor side, full range of sort of building capabilities. Like I said, there is a ton of user created content So we have question libraries that are categorized by topic. So for example, you could pop into calculus, integrals, like integration rules, substitution, and list those questions. And we've got a fair number of questions involving integration. And then, like I mentioned, also we have a ton of sort of shared courses. Again, this is all community created content. So for example, at the calculus level, we have various what we call template courses, usually aligned with some sort of open textbook like the OpenStax textbook. And that usually contains like homework for every section of the book already. Well, this one doesn't look like it does, but usually homework for every section of the book already put together. What we were really going for is, our faculty are used to the publishers, at least here in the States, that come around and basically give you teachers everything, a whole package ready to go. And particularly for our part-time faculty, the idea of having to build something themselves is not very appealing. And so in order to convince them to use open resources, we kind of needed to make it as easy as the publishers to use open resources. A teacher can come in, and if they want to use the, an OpenStax pre-calculus book, they can find a course on here and basically be ready to go in 5 minutes instead of having to spend, hours and hours even assembling assignments, let alone writing their own questions or anything like that. But yeah, I think I'll stop there and see if there are any questions.
Great, thank you, David. We do have a couple of questions. First of all, Colin Steele is asking about what forms of answer you accept. He says, you entered the quadratic in the complete the square form.
Right.
You were answering a quadratic back at some point. Can the software distinguish between the same polynomial in different forms, for example, either complete square coefficient form?
Right.
Yeah, except one word.
So by default, the system will accept anything that's algebraically equivalent. If you want to force a certain form, there are ways to force certain form, usually using sort of stupid, hacky string matching techniques. But down the road, I'm hoping to add some more clever approaches. But yes, there are plenty of questions that force a certain form by using some sort of checking the answer for certain format. So that is possible.
How are you determining algebraic equivalence?
Comparing evaluated tables of values.
Yeah, okay.
So your standard non-computer algebra system approach. So there is no computer algebra system behind the software. So it's taking more of a WebWorks style approach than a stack approach, from my understanding. So no computer algebra system in the background. Again, my goal was to make this as easy as possible to install and run. So this is literally, you can pop this on a $5 commodity web server, LAMP web server, and run it, and it works just fine.
Lovely. We had one question which appeared and then disappeared, I think because maybe you showed something. But the question was about, are people writing material for, it was called upper division course, I guess later in the degree course? So
there is, there is content for, let me see if I can hop in here. So pretty much the highest level I've seen much of is, we got like linear algebra and differential equations. Once you get past that, we don't have much. There's little smatterings here and there. Oddly, we also have physics and chemistry and accounting of all things. But not anything much higher in the maths yet, at least not on my open math. It could be that again, mostly our audience has been lower division 2-year colleges, so there just hasn't been much effort put in at that level. I think our main university users, like four-year university users, has actually been Ingo Dunn, and so maybe they've done some stuff at University of Koblenz, but yeah, I don't think there's much in the way of higher than differential equations.
Okay, so I'll follow up and say, what do you cover much at the lower end? Have you had much demand for use in high schools?
Yes, high school use has picked up quite a bit. Again, I am a two-year college faculty, so that's where most of like my promotional efforts laid. Going to those conferences, but the high school folks have started discovering it, and I would say, I can't estimate off the top of my head, but a good portion of our use on MyOpenMath is now high school users. Just for reference, we have about 100,000 students a term using the MyOpenMath server. So yeah, a lot of high school, because community college, we teach a lot of, or at least we used to teach a lot of pre-college developmental remedial classes. We had a lot of content all the way down to sort of arithmetic level. So it was fairly easy for high school folks to come in and start using it.
Great. And I have one question for you. So what are your plans for the future? What are you wanting to implement next?
Well, so the immediate roadmap, as in what I'm working on this summer, is getting LTI 1.3 working. After that, totally blanking. Sorry. I'm trying to think of things that you would actually care about, because unfortunately there's a lot of things that I've been having to work on that are not very exciting.
It's worth mentioning these things because a lot of running these kinds of systems is stuff that's not great new pedagogy.
I mean, one of the things we're going to be working on is revamping the question searching interface, because it's kind of ugly. We're going to be working on a way to do embedding of single questions in other platforms more easily. We can already do. Last spring, I spent 6 months and revamped the entire assessment front end, the assessment UI. And so we still have the ability to embed individual questions, but only using the old UI. So we need to update that to work with the new UI. Let's see. We're going to be working on sort of a minimal adaptive thing. Right now you can require one assessment to be completed before another one opens. But what we want to do is have it so that if you do really well on a preliminary assessment, it can eliminate the need to do some subsequent assessments, so that we can do sort of a mild adaptive sort of thing. There needs to be some workaround, or we'd like to do some grouping where you can force the questions to be answered in order. That's something that we had something like it in the old interface, but it just didn't make sense in the new one. So we need to figure out some way to make that work in a reasonable way. And then adding some extension abilities, like ability to do time limit extensions and retake extensions and things like that. And various question language improvements and question. I'd really like to get some new chemistry question types and a answer with units question type for the physics folks. They've been wanting that.
Great, thank you. So thank you, David, for that talk, and thank you, Matty, again for your talk. We've got a fair bit of time left in this session. So I'll quickly show you the plan for tomorrow, if I can. Here we are. So tomorrow we begin with a couple of talks, one about math support, which I think will be very similar to what David was talking about. Then a talk about a method of generating questions using SageMath. Sorry if you can hear my dog. I'm going to mute myself for a second. She's gone. Right. Then in the afternoon, we have some more lightning talks, experiences about teaching online for a course that was across the world, experiences moving to web work, and some new material in web work. Can I just remind you that about the Moodle website? We have this general questions area, the show off area, which I thought more people might make use of. If you've been doing something in e-assessment that you can link to, please stick a link in there. We have a link about the survey on German test systems, and I added something about the Euclides extension I made for drawing diagrams in numbers. So there's a lot going on, and good speakers from this session. Please make sure you have a look at the questions setting on Moodle. Right, now my dog's really losing it now, so I think we'll end it there, and I'll see you all tomorrow. Thank you very much.